All right, so you know what's coming, right? You can guess. If we spent the whole last page using norm dist, right? They gave us values like 800 and 1200 and test values. Then asked us to find percentile rank, proportions, percentages. Then it's going to have to go the opposite way, right? So here I'm going to give you proportions like 10%, that kind of thing. And I want you to give me the scores, right? The value on the test that would be. So for example, suppose Columbia only wanted to look at you if you were in the top 10%. Top 10%. So what would that mean? Well, let's start with this. What's the lower? If you're in the top 10%, that means you're in the lower 90%, right? Because they're complements, because the whole thing has to add up to 1. So what we're going to do is we're going to equal norm. All right, now again, I do .inv, but if you have old school Excel, you just do norm inv with no dot in it. Either way. And then you say the probability. Well, the probability has to be the left tail probability, always to the left. So I can't put in 0.10, I have to put in 0.90. And then the mean was 1066, the standard deviation was 191. No true or false to even put in. Enter. And there you go. You have to score a 1311. You can't do 0.76 on the test. Okay. What about the 25th percentile? Well, remember, percentile by definition is below, right? So 25% is below you would make the 25th percentile. All right. Well, that means that we can just find that equals norm inverse. The proportion below you is 0.25, 1066, 191. Just remember that norm inverse is always below you, always. So is norm dist, to be honest. Both of these functions had to pick a direction, and for a variety of calculus type reasons, they go with the proportion below to the left. All right, there we go. So you'd have to score 937. I'm rounding these because this is a real life example where you can't have 0.17 right on a test like this. If it was something that allowed decimals, then I'd keep the decimals, but this particular test wouldn't allow decimals. All right, what about 3C? Now we're going to get tricky. Now 3C is actually really important for chapter 9, so keep it in mind. So we have a middle area, and let me just put it this way. It's 0.95%. Sorry, 95%, aka 0.95. Sorry. Okay, so what's in the left tail? The left tail, well, let me put it this way. What's in the two tails? Let's do it this way. That would be 1 minus that value, right? So you have 5% in the two tails put together. So what's to the left of the left hand score? Okay, over here on the left-hand side, on the white side, on the left, right there. That would be half of that, right? That value divided by 2. Now, what's to the left of the right-hand score? Okay, so think about it over here. To the right of it is another 0.025, right? So what's to the left of it? It's 0.975, right? And you can get that by 1 minus 0.025, right? Together, these have to make 1 because this white area over here is 0.025, so is this white area over here 0.025. So what's the left-hand score? You get that with norm inverse. Oh, if you could type it right. And then you say 0.25, comma 1066, comma 191. Nobody's got troubles. So the lower score is 691.6, so 692. But the right-hand score is equal to norm inverse of the 0.975 because you need that area to the left of that right-hand score. I need all the shaded area plus that together. And that makes 0.975, and then I do norm inverse of that. So the two scores are 692 and 1440. There they are typed up.